Hello friends, sorry for interruption because of some technical snag in the communication system. It has to be rectified. Again, I am coming back right from the beginning. The goal of every emerging corporate accounts or small and medium enterprises to make profitable growth. Year over year, they must make profit, then only they can become bigger. So, what prevents profitable growth? There are mainly three factors: the poor quality, higher cost, and delayed delivery. The quality, cost, and delivery are in simple terms. QCD is the main parameters which is preventing profitable growth of organization if they are not as per the customer expectations. So the current leadership challenges for making profitable growth of every kind of companies are includes improving quality, cost, and delivery. Then delighting customers. Customers are looking for unique product which is just delivered just in time at the most attractive price. Then reducing cycle times, that increases productivity and capacity of your plant. Keeping up with technological advances, everyday technology is improving. So to keep up with the advancement in technology, one has to learn and adopt new techniques of improvement. Then reducing overall cost, responding more quickly, and increasing exports to developed countries. So these are the current challenges are to be addressed by every kind of company to make profitable growth to become the multinational corporation. So all these things can be very well addressed by Six Sigma. So this has emerged as one of the very powerful technique to enhance the growth of any company. Now let's come to the Six Sigma. These are quite mysterious to most of us. So I'm sure that everybody must have heard the name of Six Sigma, but still having doubt what is the mystery behind it, how it makes a miraculous quality improvement in every kind of process. So this is a quite advanced statistical subject. In this particular 2 hour session, I am trying to make you understand what is Six Sigma, how it can help your organization, and in simple way, without much of statistics, how the small and medium enterprises they can learn and adopt Six Sigma process to improve their quality with a real case study which as a consultant I have guided some of the industries. So once Six Sigma comes to mind of everyone, then the very first question you are likely to ask, what is Six Sigma? The second is why Six Sigma? Because already the most of the industries they are making good quality and growing. So these are the two basic questions every entrepreneur, every professional manager they want to know. So I'll try to explain it in a simple way. So coming to that, what is Six Sigma? It is a set of practices originally developed by Motorola to systematically improve processes by eliminating defects in its products. The Six Sigma is a methodology provides the technique and tools to improve the process capability and reduce the defects in any process. Continuing to that, what is Six Sigma? It is a performance goal representing 3.4 defects per million opportunities to make one. So here in the quality measurement shifts from a percentage defect to parts per million defects. This is the major shift in the thinking of in terms of the Six Sigma. A set of tools and methods used to improve or design world class quality products and capable processes. It is a statistical measure indicating the number of standard deviation within customer expectations. A disciplined fact based approach to managing a business and its processes. It is a means to promote greater awareness of customer needs, performance measurements, and business improvements. So, this is just about What is Six Sigma? This will be further clarified once I proceed further and give explanation of various terms. Whenever you are having any doubt, you can ask question anytime just by typing your queries on your computer display. So let's have an overview of Six Sigma. As you see this, the triangular pyramid. So this can be called as a Six Sigma is a philosophy, it is a process, and it is a statistical tool. So as a philosophy, it is addressing your urgency, your pains, and it is essential for the survival and growth of companies. It drives higher cost out. It helps in a reduction of a cost of your products. So as a statistical tool, this is addressing the urgency, the requirement of your customers, and reducing the cost. As a process, it helps to grow your process capability, people competence, and overall productivity of your production processes. As a philosophy, it is a transformational tool to transform your organization from a current traditional way to the most modern method of quality improvement. And it brings a change in the world of your organization. Let's see how these three aspects of Six Sigma, the philosophy, process, and statistical tools help your organization to transform. So, as a philosophy, if you take it, anything less than ideal is an opportunity for improvement. So, it gives a challenge to every employee of the organization to achieve the ideal, means what is the global benchmark. So, any defect that costs money and that reduces your profitability. From a philosophically, any deviation from specification, it means you are losing your profit margin. Then understanding processes and improving them is the most efficient way to achieve lasting results. So, as a philosophy, Six Sigma helps you to talk to your process, to learn about your process, and find out the means how to improve the process so that long lasting results are there to support your profitable growth vision of your company. Now, coming that as a process, how it helps to achieve this level of performance, you need a structured methodology which is called define, measure, analyze, improve, and control, or a DMAC process of managing the problems as a project and solving the problem. So, now, as a statistical tool, it is a process will produce less than 3.4 defects per million opportunities. Currently, we are measuring the defects in traditional TQM way, quality management way. We measure the defects in percentage, maybe 1%, 2% defects you might be making. But Six Sigma process can help you to get 3.4 defects per million. It means that 0.00034% defects. Generally, today we are measuring the defects in the even two digits up to 10%, 1 to 10%, but Six Sigma helps you to attain defects to the level of 0.00034%. So, this way, as a philosophy, as a process, as a statistical tool. Yeah. Hmm. Should I continue? let's further go deep how Six Sigma works as a philosophy. Figure out. Sorry, friends, because of some technical problem, we had to interrupt. Again, coming that overview of Six Sigma as a philosophy, as a process, as a statistics. Let's see, go in detail how Six Sigma works as a philosophy. It helps to know you what is important to the customer. A typical methodology critical to quality and the customer value are the key objectives of attaining the Six Sigma. So, as a supplier, you must analyze and know what is critical to quality, what value the customer is looking from product supplied by your company. So the philosophy helps you to go in deep. Then reducing the defects, taking a new approach that is totally new for all the industries because of the statistical techniques. So defect DPMO means basically defects per million opportunities. So you have to find out what are the opportunities in your processes to make the defects and then measure and reduce defects per million opportunities to level of parts per million. So it centers around the target. The mean is the basically what is your target, what is the customer specification, the mean value that becomes the target for every process to attain exactly what is needed with minimum tolerance. Then reduce variation. So variation is measured in statistical terms as a standard variation. I'll explain further. So, as a philosophy, it helps you to understand the what's important to your customer and how to measure and monitor defects per million opportunities, means going from percentage level to the ppm level, parts per million level, and focusing on a specific target, which is a mean, and reducing the standard variation in the process. So, Six Sigma as a process, it uses a very structured methodology to solve the problem, to improve the quality, which is called a define, measure, analyze, improve, and control. So, define means whenever any defect or any deviation from a specification occurring, or the cost is going high, or the deliveries are getting delayed, so it is happening because of certain problem. So, as a Six Sigma as a process, it first identify what is the problem which is impacting adverse impact on the quality, cost, and delivery. It is defined as a problem. Then next step of the process is measure. What do we need to improve? So that is identified based on the actual data collected from the process. Once data is collected, the third step of Six Sigma process is analysis of the process to find out what is the root cause. And the fourth is once root cause is known, then solutions are evolved and implemented to improve the process performance. And ultimately, the fifth phase of Six Sigma process is the control. Once solutions has been implemented and desired improvement has been achieved, then to sustain the gain, there has to be a control to make the process stable and revise the new operating procedure. So Six Sigma as a process is known as a DMAC process. So, how it helps? Six Sigma defines problem statistically. So far, we are just collecting data in the percentage, simple arithmetic level. Now we go more deep in the identifying the problem and then defining them statistically. The very simple relationship used probably in the middle school we studied in the algebra, y is function of x's. There will be the y is the effect and x in this equation, y is the effect and several x's 1, 2, 3, x1, x2, x up to xn are the causes which are impacting the defect. So the defect is an effect of certain variation in the variables known as x. The characteristics of y and x functions is that y is the dependent variable. It is the output of any process. It is the effect of the variables. It is a symptom and it is monitored. And whereas the x are the causal factors, which they are independent variables, they are the input of a process, they are the causes, they are the real problem which is impacting in the output, and they can be controlled. So this way, starting with a algebraic equation of y is a function of x's, so we try to establish relationship. So statistical data is collected based on this function and they are analyzed and solution is evolved. So as a Six Sigma as a statistics, as I told the overview, Six Sigma is a philosophy, Six Sigma is a process, and Six Sigma is statistics. So these are three characteristics. How it is a statistics? It is a disciplined method of using extremely rigorous data gathering and statistical analysis to pinpoint the errors and ways of eliminating them. So the term sigma means standard deviation. I'm sure most of you must have studied the statistics, the term standard deviation. So standard deviation measures how much variation is taking place. Standard deviation is the key factor in determining the acceptable number of defective units found in population. So you can go back to your knowledge of statistics where standard deviation is the key factor which is going to control the quality of product by controlling the variations. So again back to your statistics classes during the graduation. So what is a sigma means we must understand. It is a term used in statistics to present standard deviation from mean value. It is an indicator of the degree of variation in set of process. I'm sure many of you must have calculated standard deviation in various processes by taking a number of data, taking the mean, and then reducing each value from the mean, and then uh, adding by squaring it and taking under root of it, square root of it, and that way the six sigma or the standard variation is calculated. Its sigma measures how far a given process deviates from the perfection. So it is number of value of the sigma that gives how far the process is deviating from its target. So this is written in this way, especially the Greek alphabet, and very famous in the statistics. So now comes that second question. I'm sure up to some extent you must have understood what is a sigma. It is basically deviation from the your specification. More the deviation, more the defect will come. So now the second question is why Six Sigma? Six Sigma emerged as a natural evolution in business to increase profit by eliminating defects. By calculating the standard deviation, we try to relate with the causal factors, and by eliminating the causal factor, the deviation from the uh, target value can be minimized. So, this by eliminating defects, we can increase our profitability. The current business environment now demands and rewards innovation more than ever before due to customer expectation. Just by having a global competition, now in our country, you can find product from all leading developed countries, whether it is from US, Japan, Europe, all the quality products are available in our market. So once the market is open to global standards, then expectation of customers that goes up. So technological change, technology is changing at the very rapid speed. So with the change in the technology, we have to continuously update ourselves and improve our process. Then the global competition, especially for the small and medium enterprises or the emerging corporate accounts, you must be facing a lot of competition from the Chinese product, even the toys, even the domestic electronics items, clothing, everything means even in the uh, industrial items, capital goods, the China has become very competitive. And to face this global competition, we have to improve the quality where Six Sigma can help every kind of industry. Then the market fragmentation. Here the market is market is fragmented into different sections, different segments. Today we cannot have the same product for all type of industry. So every segment requires a specific quality. So the Six Sigma can help the industries to produce quality as per the requirements of special segments of the market. Let's try to understand the sigma scale quantitatively. Here in the world of at a 3 sigma, 3 sigma is means lower process capability. There are 964 US flights cancellation per day. If it is happening, then if the same process is improved to 6 sigma, there will be one US flight is cancelled every 3 weeks. The police makes in the 3 sigma process, the police makes 7 false arrests every 4 minutes. So with the 6 sigma accuracy, there are fewer than 4 false arrests per month. If in hospitals 5,390 newborn are dropped each year, then just by improving the process by to 6 sigma level, a newborn is dropped every once every 4 years in the hospital. In 1 hour, 47,000 international long distance calls are accidentally disconnected. This happens quite often with a poor process. Now, with the Six Sigma, it would take more than 2 years to see the same number of dropped international calls. With these examples, now you can visualize up to what extent defect can be reduced by improving the process to Six Sigma level. Another very practical example why the landing of any flight, it's very important. The pilot he has to follow the indicator lines given. If pilot always lands within half the landing strip width, we say that he has Six Sigma capability. So here accuracy of the landing that minimizes the chances of accidents. So this way Six Sigma can be applied even the hospitals, by the police forces, in the manufacturing, even the operation of aeroplanes. So this way, how this Six Sigma brings more accuracy in operations. So leading companies of Six Sigma are nowadays means the earlier it started at Motorola, then Sony, Citibank, General Electric, Ericsson, Ford, Toyota. There are so many companies. They are earlier now, but it has the list has become very vast. Even in our countries, many companies they are following the Six Sigma. So the Six Sigma is not just a target; it is a journey. It is a culture. So once any company is trying to learn the Six Sigma, gradually they reach to up to 3.4 defects per million. So methodology, there are two types of methodology used in the normal existing operations, the processes. It's called DMAC, define, measure, analyze, improve, and control. This is used for improving the running processes in the most of situation, most of the industry. They have to learn the DMAC methodology, which I'll be discussing in the coming slides. And another new product or design of a process. It is called DMA/DV. It is a define, measure, analyze, design, and verify. This is also required the companies those who are designing new product. Most of the companies now innovating it. So the R&D people, product development people, they need to learn, define, measure, analyze, design, and verify methodology. It is the similar steps, and whereas the production people and other operations they need to follow the DMAC approach. So these two methodologies are used. Coming to that, what is a DMAC? This is a abbreviation of five phase problem solving process or the quality improvement process as a define, measure, analyze, improve, and control. It is a logical and structured approach to solve a problem, to make the improvement in the process to deliver better quality, lower cost, and on time delivery. It's an iterative process in the continuous improvement process. It's not just one time. every process has to continuously improve. So the DMAC will help the professionals to make continuous improvement in their process performance. It is a quality tool which focuses on the change management. So the basically, if you see the Six Sigma or the Lean or any new improvement methodology, nothing but change management means it means that changing from the current way operation to the better way of operation using the new techniques. So this is the change management methodology. As a Six Sigma process, as I told, define, measure, analyze, improve, control. Each phase, these are the five phases of any Six Sigma project. So the objective of need to be improved. What are the opportunities for making improvement? There are so many set of like quality. See that COP concept. Profitability of the company, society, everybody is at this. So this helps to address everybody's voice, then helps in designing the project charter, how to move the project. So the objective, the second phase is the measure phase. So it measures the current way of operations, collects data, what are the exact data, and then those data are analyzed to identify the root cause. Why the defects are taking place, why the deviations from specifications are occurring, why the cost is going up, why the delays are taking in delivery. All these root causes are analyzed based on the collection of data. So once the data is collected, the real root cause is analyzed by the people, then solutions are evolved. In fact, everybody knows the solutions to the problem, but they don't know what is the problem. So the Six Sigma helps accurately reach to the problem and its cause. So once the cause is known, you design a solution and implement the solution. Once solution is then comes the fifth phase of project is the control. So that the gains are held and process becomes stable and that becomes the culture and new operating method of the company. This way, Six Sigma process works to the demand. When to use Six Sigma? Its usage depends on type of business. In general, if there are processes that generate a lot of negative customer feedback, whether that customer is internal or external, the components of Six Sigma should be considered. It needs to study and rectify the problem. Whenever the defect rate in your process is very high, is much higher than the global benchmark, when lot of complaints are coming from the, when your cost competitiveness is reduced, when the deliveries are delayed, it means there is some problem in your process, and you can apply Six Sigma to improve the quality, cost, delivery, even in the case to reduce the accidents, to reduce the pollution. All these things can be also solved by using the Six Sigma. So, what are the benefits of Six Sigma? It generates sustained success. What is the success? Is the profitable. So it has to be sustainable. So Six Sigma, by improving the processes and competence of the people, it brings sustainability and stability in your operation. Sets performance goal for everyone. So far, people are working in most of the SMEs or the most of the even the large companies without the specific goals because they don't know what is the standard. So this helps to set a clear, specific performance goal for everyone so that people can put their effort to achieve, attain that goal. It enhances value for the customers. Today, customers are not just looking for the quality, but as a bundle of factors, which is which includes the value. So the value can be increased by applying the Six Sigma in the process. It accelerates rate of improvements. So for the improvements, we are taking longer time, but because of a structured methodology of demand, it sets a timeline so that the improvements can be done faster within the specified time. It promotes learning across boundaries. That's very important here. Unless the people learn and new techniques, they cannot deliver good performance. So Six Sigma makes people learn the new methodology, new approach to solve the problem. It improves global competitiveness of the company just by, as I mentioned, improving the quality, cost, and delivery. These three critical factors for the customer concern. It improves overall profitability. So Six Sigma, that is helping the organization to make more money, make profit. It helps the customers to get better quality product at competitive price. It helps society by contributing more profitability, more productivity, more GDP to the country. It helps in generating employment by growth of the industry. Now, coming that briefly, what are the tools and techniques of Six Sigma? In fact, Six Sigma uses a lot of tools, and there is no need of learning all the tools in the at a time. As you as a Six Sigma expertise grows, the people involved in the Six Sigma implementation gradually they learn tools, more and more tools as they practice it. So one should not be afraid that means a lot of learning will be there. You can start with the very simple 7 QC tools, which I'll explain, and I'll give example also. There is no need of going very advanced statistics, especially in SME, just by applying simple 7 QC tools and simple statistics. Even the small and medium enterprises can very effectively apply the Six Sigma. As you see here, the foundation is the process mapping. One has to learn the process mapping and then 7 QC tools. Sometimes back I conducted workshop on 7 QC tools also, and the team project management by demand. So I recommend all of you to start with the process mapping, learning the 7 QC tools, and use the DMAC methodology of project management to start with the Six Sigma. As you will grow, get the better results, then gradually you can learn other measurement system analysis, capability study, cause and effect matrix, multivariant study, FMEA. There's so many tools are there. So this is a long journey. It cannot be just learnt in one day. Even I have undergone black belt training. The 5 months training was there at the beginning, and so this is a comprehensive subject, and one has to devote a lot of time. But I'll try to make you simple how just by process mapping and DMAC methodology, by using 7 QC tools, you can start your Six Sigma journey. So these are the 7 QC tools are used throughout the world. The real quality guru of Japan, Koro Ishikawa, he his statement that 85% of problems of any process can be solved by the 7 QC tools. So my strong recommendation to all SME people, please try to learn the SME QC tool in very detail. You can go back on YouTube in the eCafe site, and there is already one 7 QC tools with very nice practical example. I have conducted one webinar, and you can take the training from some management consultants. So these are 7 QC tools are the flow chart, cause and effect diagram, control charts, checklist, histogram, Pareto charts, and scatter diagram. These are how these can be used to solve the problem. To begin with that, you can apply Six Sigma with the 7 QC tools only, and gradually, as you gain expertise, you can learn other statistical methods. So coming to that simple overview aspect of the Six Sigma, the conclusion is that it is a methodology used for aligning key business process to achieve the purpose. What is the purpose of any organization? To get the to provide most competitive QCD package of value to the customer. How it can be done? By perfecting your processes, utilizing rigorous data analysis to minimize data variations in those processes. As mentioned earlier, so the variation is the main problem, and by statistical analysis, we can identify the cause and minimize the process variations so that the standard deviation of every process is minimized. Driving rapid and sustainable improvement to business processes. There has to be time bound improvement, and it has to be process has to be very fast. So Six Sigma, the DMAC process help you to complete any improvement journey in lesser time. It improves processes and people capability to meet the customer requirements. The process and people both are equally important. Very good process with less competent people is not going to serve the purpose. Or the highly competent, knowledgeable process people with the poor process, again, it's not going to solve. So, recommendation is that you must improve the process and the people simultaneously. Just buying new technology, no company can improve its performance unless the people competence is improved to match that technology. So this is a people and process both are equally important. So finally, Six Sigma develops a culture of continuous improvement. Why continuous improvement is required? Because every day technology is improving, innovations are taking place. All other competitors, once they are improving their technology, just to keep the pace with the technological development, every company has to develop a culture of continuous improvement. Then only it can survive and grow. So this way, I have given just overview of Six Sigma. It is what? It is a philosophy, it is a process, and it is a statistics. So just by learning and implementing this process, these techniques of Six Sigma, any small organization can attain a sustainable growth. Now, coming to that, how it works. Are you having any question about the Six Sigma? What it is, how it works? Now, I'll come to that. How it works. The approach is that there are some practical problem happening in the soft floor. Just like let's take example of defect rate has gone very high from usual 2% benchmark to it is coming 6%. So it becomes practical problem that my defect rate. So why it is happening? There may be something wrong in the process going on, but we don't know it. Now we try to find out is convert that problem a statistical problem. How? Just by calculating the standard deviation, collecting some data, and making standard deviation so it becomes a standard problem, a statistical problem. Then from that statistical analysis we try to equation of y is equal to function of x's. We try to find out solution which particular variable is causing the problem. This can come this can be known because of the variation in the various variable parameters. So this way, statistically, the reason for the variation is identified. Then the same problem is converted to practical problem. So, say for example, your process means in a production process, your defect rate, which used to be 2%, it has gone to 6%. So by collecting data, once we come to know that by analyzing all the problems, say for example, we found that the last 2 months our raw material quality has changed drastically, and which is causing the increase in the percentage. So by just analyzing all the data, related possible data, we come to know that raw material quality has changed. Is that's not coming exactly as per specification. That's so by a statistical analysis we try to find out means the cause, the real cause of high defect rate was the raw material quality because we could not track it. So now coming to the practical solution, so more stringent quality control implemented in the raw material quality. The supplier has been provided a proper feedback, that means what variation is coming, and in fact facilitating your supplier to control that variation so that again you get the right raw material. So this way, a practical problem to statistical solution, then finally practical solution. This way Six Sigma works. Let's have a very practical example. Say in your company wants to conduct training of employees. So the all employees, they are attending the training program right from the 9 o'clock to the 5 o'clock. So during to 1 to 2 o'clock, there is a 1 hour lunch break, and during that lunch break, you have to provide them a fast food lunch so that it can be finished in less time and more time is spent on the learning. So you have to decide which company can provide the lunch break so that within 1 to 2 o'clock everybody finishes lunch. Here the time set means you invited two companies to select for the selection of the right supplier, and 10 days the actual delivery time was noted down, and you have given the company to supply the pizza 20 pizzas every day between 1 to 2 o'clock, right? Here, daily at 13-15 hours with permissible wastage, given the by quarter past 1, they must supply the pizza. Maximum variation can be there 15 minutes. Means it can be between 1 o'clock to 1:30, they must supply the pizza, 20 pizza, and the delivery time of both the companies were recorded as you see on the screen for 10 days. Now, these data were collected statistically, and here statistically a histogram was made. What was that? Mean was that the time exact target was 13 hours 15 minutes. 1 hour, quarter past 1, they must supply the product. That was the target. And the earliest they can do at a 13:00 hours and latest by 13:30. So when all the data are put statistically in the this type of histogram, you find that the one pizza world which delivered twice, it was beyond the specified hours, means two defects were there in the delivery of the pizza world, and then but at same time Domino Pizza, that there was zero defect, they supplied within specified time for all 10 days. So this helps you to come to know that now quite obvious which company you will order for the regular pizza, the Domino Pizza, because of the statistics and their defects were zero. So this way Six Sigma is used for selection of a right vendor. At the same time, it is a good lesson for the pizza world how to reduce their deviations so that they come within the limit specified by the customers. So this way Six Sigma can be used. So the what is the main Y factor? The effect is the here let's take the quality defect is the biggest challenge for the every kind of organization. Let's take an example here. As you see, this is a company producing auto components, lot of sheet metal work is there. at the end of after the production, at the end of assembly line, an inspector checking every component and throwing out defects. So the more the defects, more the cost of production, more loss to the company, and more delays. So overall, the any defect that is impacting in the higher cost, higher customer dissatisfaction, more inspection costs. This way, the main challenge is that how to reduce the defect in any process. So first we have to find out what makes the products defective. Here is the key. Here the most important term for Six Sigma learner is what the cause of defect is the variation. Variation is the enemy for the every organization. The more the variation from the standard, more the cost, poor the quality, more delays, and lesser profitability. So variation in the why the defects are taking place, it is some variation in the materials or machines, methods, operations, measurements, environmental factors. These are the cause of defects. Some changes from the standard taking place in these variables that is coming out as a defect. Sigma refers to standard deviation, a measure of variation. How to measure what is the quantum of variation? Standard deviation is calculated from the data that gives the what is the quantity quantum of the variation. Six sigma refers to a process having six standard deviations between the target and actual limit. Here, as you see, first you have to calculate the standard deviation in the process. So, in the if in the target value to the upper or lower specific limits, if it is six standard deviations are fitted in that, it means that sigma value is less and your process is a very much controlled. So this way, six standard deviations that makes the company as a Six Sigma process. What does variation means? Let's see this graph. Variation means it is coming up and down, and the black one here. If you just see the target value is a zero, but we are getting lot of ups and downs in the performance. So it means what variation means that process does not produce the same result. Why? The process is not stable and the results are fluctuating. Some variation will exist in all process. This is a law of nature. In all the processes, there will be some variations because of the natural and inherent causes that we cannot get the exact straight line in all the process. Variations, but some variations are much beyond the limit. They are the special cause variations. So variations directly affect customer experiences. More the variations, more more variation in the experiences of customer, he'll be happy and happy. So customers do not feel averages. Let's take very practical example. You are traveling in a car and driver sometimes he drives at a 20 kilometer per hour and suddenly goes to 80 kilometer per hour. So average becomes 50 kilometer per hour. At the same time, another driver he is going between 45 to 50 stable. Which one is more comfortable to you? Both are having the same average, but which you will prefer? The quite obvious, which is going around the 40 to 60 means so the average is same but stable. So the same phenomena applies here. We are not just bothered about the variation, we are bothered about what is the quantum of variation, the range of variation. The lesser the variation, more stable the process. So this Six Sigma works tries to bring in that way. Let's take another example. Process variability. Actual variability is indicated like this curve. This is a normal distribution curve. So there are two things are important once you are making a process, even you can apply it today itself. Here the measurement instruments and measurement technique is equally important. Sometimes what happens, even your product is good, but because of the poor measuring instrument and poor knowledge of the inspector who is measuring it, even the good product can be branded as a defective and it can be thrown away as a defective. At the same time, because of the wrong measurement methodology or more measurement variability, even a bad product can be accepted as a good product. Let's take a practical example. You go to doctor, you are having some problem of a blood pressure. If doctor uses the correct blood pressure measuring instrument, then whatever prescription he recommends you, that will cure you. But at the same time, you go to another doctor whose instrument itself is wrong. It's not properly calibrated, it is defective. So even if your blood pressure is normal, it will read abnormal, or abnormal your blood pressure, then it can read normal. So in both the this situation, one measurement system is not stable, instrument is not correct, and the person who is measuring not competent, then again it is going to be equally dangerous. It can create defective. So these are the two things are very important: process variability and measurement variability. So you can, even from tomorrow itself, you can make sure that quality measurement, inspection measurements are done correctly, and the instruments are properly calibrated so that they are reliable. So the total variability of the process and variability, measurement variability, that goes much higher, and this is the much bigger problem. So both has to be addressed: the variations in the process, variation in the measuring instrument, both are equally important. So what causes variation? This is the main concern. If you want to improve quality, first you have to measure what is the variation quantum. That can be statistically calculated by standard deviation. Now comes that to improve the quality, you have to identify the cause and take appropriate remedial solution to eliminate the cause. There are two types of, from the Six Sigma perspective, there are two types of causes that for the variation. First is the common cause. It is a random variation within predictable range. This is usual, inherent in the process. There is no pattern inherent, and adjusting the process increases its variation. So some inherent common cause variation, always there will be some fluctuation. We have to just need not bother. Now the concern for the Six Sigma or the quality professional is the special cause variation, which is non-random, which happens sometimes and periodical, may exhibit a pattern, and assignable, explainable, and controllable. So the special causes, they show a pattern, and that need to be identified and that need to be solved. So adjusting the process decreases its variation. So here the common cause variation are just nominal, inherent in process. We need not bother for it. But non-random variation which are coming in a pattern, that need to be addressed by that. And how you can come to know? Unless you follow the Six Sigma process, you can't find out which is the common cause variation, which is the special cause variation. So this helps you to identify the real problems in the process from the statistics. Now coming that, these are the basic foundations of Six Sigma. What are the sources of variation? Here, these are classified. The four main areas of variation is the design. Variation in the design. If it is not stable, then because the people are on the shop floor or the who are making the product, they follow the design. If variation in the design is there, it will cause defect. Then the process capability is the main concern of Six Sigma. Basically, we have to improve the capability of process. It means the process capability, higher the capability with less variation, that is, capability improves. So the process capability is the greatest challenge. Then comes the measurement system. How accurate and stable your measurement system. The person who is doing quality inspection, his quality, his competence is very important. The kind of instruments, testing machines he is using, he or she is using, their the reliability, their the tolerance, their calibration states are equally important. And then the fourth major area is the material stability in the incoming material composition, incoming material properties. There has to be continuity, there has to be stability and similarity. So these are the four main areas of variation which are addressed in Six Sigma. Is the design variation is design, the process capability, measurement system, and the material. So so the goal of Six Sigma, if you just remember the pizza parameter, the more the defects, you will get the, this is called a bell curve, very wide bell curve. And most of the bell curve, this is lower specification limit and upper specification limit. It means all the product specification quality should be within these two limits. If it is going beyond that, it means that you are discarding a lot of product as a defective. The purpose of Six Sigma, as you see, the wider spread has to be compressed so that all the output specification comes within the specification limit. Like here, as indicated, Six Sigma that makes the process capability 99.9997%. So this way, Six Sigma process helps you to improve the quality level. Six Sigma process, as you see that if you see there is lower specification limit and upper specification limit. Whatever the customer gives, there is always, say for example, I want a bolt whose diameter should be 3 millimeter plus minus 0.003. Like this one specification comes. Then how it is put in Six Sigma? The process standard deviation, if it is 6 here, Six Sigma process, if 6 standard deviation fit between the upper or lower specification limit and the target value, then the process is highly capable. So by reducing the variability of the process, we improve the quality. So let's see how it can impact Six Sigma. If it is a one Sigma process, only 30.9% good product you will get, and 69.1% is rejected. It means more than 691,000 means in per million, more than 690,000 per million is rejected. So if it is two sigma process, 69.1% and defects are 30.9%. If process is made to three sigma, defect will be 6.7%. Process sigma is 4%, 4 sigma, then 0.62% defective, and 5 sigma 0.023% defective. And once a process becomes 6 sigma, then 0.00034% defective maximum you can achieve. But here again I'll tell you that it is not a magic. Suddenly you cannot achieve Six Sigma in one go. Most of, if you just take actual percentage of your defect rate, most of the companies will be operating between 2 to 3 sigma level. Very few are in 3 to 4 sigma level. So once you apply the statistical method gradually, from if you are operating at 3 sigma, you can attain by improving the process to 4 sigma level, 4 to 5 sigma level, and 5 to 6 sigma level. It it will take time. It is not just a miraculous or magic word. Means as you start learning Six Sigma methodology, gradually you will achieve to Six Sigma level. It's a long journey and very disciplined approach. Lot of learning, lot of discipline, lot of practice is required. But this is the only way how a company can grow in the quality front gradually. So this is the way you can see. If you see, most of the companies must be producing defect between 2 to 10%. Means either means between a 2 to 3 to 4 sigma they might be operating. So this is the impact of Six Sigma. Let's take another example. A building block company which is making cement blocks. Imagine that you are a chief operating officer of a modern building blocks limited that makes cement building blocks used in the construction sector, in the roads and all construction. Each block is supposed to weigh 20 kg with permissible variation of plus minus 1 kg. But due to variations in process parameters, some of the blocks are overweight up to 21 kg and some are underweight to the extent of 19 kg. So blocks out of the range which is less than 19 kg they are scrapped, and which are more than 21 kg both are scrapped. So this way, now you have to find out your mean value is that 20 kg you must get it. If it is not coming between 19 to 20, then you are losing money. All blocks become useless and cost of blocks that increases and your scrap is going up. Now see why these variations in the weight. Now you have to find out why the variation in weight is occurring. Let's go on the variation is the factor, defect is the why, and what are the factors which is causing the variation in the, it is the variation in composition of the mixture which is containing cement, water, stone and other ingredients which are used for making the block. First is the main thing, the variation in the chemistry of the mixture you are making for molding the block. Then second becomes variations in the measurement, because ultimately I have seen in the construction sites mostly it is manually done by one typical volume measurement in a steel Tesla or whatever they call it. So variations in measurement. If measurement are not consistent, then every person who is taking the materials for mixture, there will be variations in the measurement method. Then variations in mixing and molding process. There are some manual mixing is done, somewhere the mechanical mixing is done. Then the molding, how the molding is done, what pressure is being applied, how fast it is molded. Means there are so many factors which may impact the volume may be same, but the weight may be reduced, or the weight may be same, but the dimensions can be reduced. So variations in environmental factors, like in summer, the environmental factor are up to 40 degrees temperature. At the same time, winter it can go up to 15 to 20-degree temperature. So because of these variations in temperature, they may cause in variation in the weight of block. So once we try to find out what are the variations in, what are the various parameters which are impacting, we have to collect data for each parameter and analyze relationship between the variation in the block weight, and this way finally we can pinpoint what is the exact reason for the weight, whether it is a measurement or the mixing method or the weighing methods or the molding method or the environmental factors. This way Six Sigma analysis help us to find out the exact parameter which is impacting variations in the output, and then find special measures to control those variables. So, what are the causes of variations? I explained there are two types. Is part of any process. Chance causes, which are the inherent, which cannot be controlled. Some variation will be always there, which is, but it is not in fact the defective. That's why the in case of cement blocks, we have put the limit what is specified 20 plus minus 1 kg. It means 18 to 20, 18 to 21 is acceptable. Why we need 18 to 21? Because some chance causes are there which cannot be controlled. So there will be always variation of plus minus 1. That is acceptable. But once the block weight comes 16 kg or it comes 25 kgs, it is because of some assignable cause, something for which identifiable region can be determined. If some abnormal variation beyond the upper and lower specification limits, it means we have to find out some special causes which are called assignable, which can be detected, which can be controlled. This may be wrong tool, wrong operation, wrong measurement, so wrong method. So these are the tools. Means first here the problem is that means to find out the real problem of defect is we have to reach to the assignable cause. How you can reach? By collecting and analyzing the data in a statistical manner. Let's take further elaboration. The same example again, the cement block manufacturing. Original process is making like a defect variation is much higher range, which is because of uncontrolled methods. So the first step, go and see the real process, gather data and plot study. Here the comes statistics. Unless you collect the data and make a run chart, make a proper chart, you cannot find out. You have to calculate the standard deviation, you have to make a chart. The red line indicates the target value and the fluctuations. In the original process, you find fluctuation was very high. Now identify and remove special causes. Because special causes, fluctuation was much higher and it was getting rejected. Rejection rate was high. Now identify and remove the special cause. So of variation to stabilize the process. Now by analysis we found that the special causes and reduce minimize the variation. So the process means variation, that is because of the inherent cause there will be some variation, so the process is improved. So here the defect rate in second situation will be much lower than what was in the first process. Now, third, turn attention to continual improvement of the system process. Now, the purpose is that means we have to continuously improve the process so that the process becomes more stable and the results are better. So, how you do it? PD, Plan, Do, Standardize, Act. Plan, Do, Standardize, Act or DMAC by using define, measure, analyze, improve, and control, applying the process. So this way we can continuously improve the process to minimize the variations. So getting improvement is basically again coming to the same bell curve. This is the main thing which is used in Six Sigma, the lower specification limit and higher specification limit. If it is covering much higher here, if you see the plus 3 sigma this side and other side, both side, 3 standard deviation are coming within the limit, then it is 3 sigma process. Why the 6 sigma process means if you see here 1, 2, 3, 4, 5, 6. If standard deviation is reduced to that level so that between the target value and the specification limit it becomes 6 sigma can be fitted, then it becomes a much more process. It means 6 sigma means standard deviation has value has been reduced to very low so that process becomes narrow and the defect rate practically becomes negligible up to 3.4. If you see in this case all 99.9997% is coming within the specification limit and the performance quality performance of the process has gone up. Now comes to the how to improve quality. Again, I am coming back to the process. Three things, if you remember, the Six Sigma is a philosophy, Six Sigma is a process, Six Sigma is statistics. First, I recommend you accept as a philosophy. You try to understand the, what is important to the customer, then try to find out statistically as a process why the your performance is coming beyond the target value. So here the process of define, measure, analyze, improvement, control is used to solve the problem. If defect rate is high, you take a project and here the select the project, define the project objective, form the team. Here the if defect rate is coming abnormally high, it means there is some problem in the process. How to solve that problem? Now the Six Sigma process is used. Define the problem, select a project, define the project objective. Say, for example, your defect level in your company has gone in a particular process. It was 3%, but it has gone to 6%. It means there is something wrong in the process. So define the project. Objective becomes okay, we have to bring down the defect level from 6% to 2%. That is the objective, target is set. Then form the team. You have to form a team. Here the team is not just the production people, not the quality. It's called cross functional team. In this, whoever is impacted by that defect, they should come and form, be a part of team to solve the problem. Here the like production people, quality people, marketing people, maintenance people, materials people, all they should be in a team so that the problem can be seen from different angle. Then the map, the process map is a sequence of operations that has to be mapped. Then identify customer requirement, what is exactly your target value, then identify the priorities and update project file. So this is the first stage of define, these are the activities. Then once you have completed the define phase, then comes the measure. Define measures, as I mentioned earlier, y is a function of x1, x2, x2. So apply the same algebraic equation. If defect is taking place, y, the functions variables may be the material, maybe the machines, maybe the methods, maybe the measurement, may the competence of the people. So you just miss which may, based on your experience, you identify which are variables may be impacting the higher defect rate. Then evaluate measurement system. Then make sure that whoever whatever the data is being collected, the measurement system, so that the variability in the measurement is minimized. So first you have to check whether my measurement system is right or wrong. Like as I gave the example of a doctor, before testing the blood pressure of any person, first he must ensure that he must check that whether his instrument is correct or not. Instrument is properly calibrated or the measurement taken by observed by the instrument is correct or not before measuring. So here this is a very important. In the most of the organizations we see that they are never checking about the measurement system, instruments of the measurement. So now determine the process stability. Now with the collection of a data, you just make the bell curve. It is like as you see in this particular figure, a histogram is made. So this shows the normal distribution. Now set the target for the measures. Means data collection in this whole process, the maximum time is taken in the measure phase because you have to collect the data and data has to be accurate. More longer time you have to take the fresh data from the process, not the historical data. So the data collection plan has to be made. Then third, once data is collected, then analysis is done using a lot of statistical tools, even software. There is a software, famous software Minitab, generally used throughout the world, but that's needed in advanced stage. The semi they don't need. So identify the potential x's, y and x relationship and cause and effect. What may be the probable causes of defects occurring? There are two most important tools. One is called cause and effect diagram and YY analysis. This has been explained in the 7QC tools webinar. So analysis is done to find identify what is the exact cause of the problem. Once cause is known, this is up to here analytical. Now here you have to make improvement, generate a lot of solutions, use the knowledge of process experts, experienced people, generate number of solutions, not just one. And out of number of solutions, select the most appropriate fitting to your situation. Sometimes some solutions may require a lot of capital investment, which may be difficult for the company. So, which is the most practical, most cost effective solution? You select one of the solution and then implement. The second improvement phase is the longest in the whole system, because you have to test your solution once the results are coming, and in due course of time, if it becomes a stable process, becomes stable, the variations are minimized. Then comes the control phase. You have to make sure that standard practices are revised, SOPs are revised, people are trained to operate as per the new methodology. And this is the control phase to make sure that whatever improvement that you have made, you hold the gain. So, this way, the process of Six Sigma project management is define, measure, analyze, improve, and control. Let's go a bit more detail in the each phase. What is a DMAC? The first phase is define, identify the customers and their priorities, what they are looking. You have to contact, it may be internal customer or external customer, to identify their priorities, identify business objective, means reduce cost, improve productivity, means all these things has to be put, select a Six Sigma project team, then make a team, define the critical quality. This is a very nice concept. What is the most important critical to quality, that has to be identified. Just like in our body, what is a critical to our living is the most, if you see the CTQ basis, the most important organ of our body is the heart. That is a critical quality. If heart stop functioning, everything goes. So the CTQ in our health is the cardiac system. So the same way you have to identify in each product what is critical to quality from the angle of customers. So this is the define phase. Then the second is the measure, determine how to measure the process. Identify here the why and function of X1, X2, X3 that has to be established. Identify key internal process that influences critical to quality. You have to collect data from the key internal process which are CTQs. Measure the defect rate currently generated relative to those processes. Collect the data and measure the current rate of defects being generated. Then third, determine the most likely causes of defects. From the data by cause and defect analysis and YY analysis, identify key factors that are most likely to create process variation. Here, as I mentioned earlier, the what causes defect is the variation, which is there are so many thousands type of variation, which is the key variation which is causing a defect, that is to be identified if your data are correct and proper tools are used. Then comes once analysis is done, you know the root cause. Then improvement phase comes. Identify means to improve causes of the defects. Confirm the key variables and quantify the effects on CTQ. So, applying your wisdom and expert advice, you find out what are the solutions for the problems, root cause identified. Identify maximum acceptable range for the key variables and the system to measure deviations of the variable, and modify the process to stay within the acceptable ranges. It means bringing change in the process either by technological improvement or by process cycle improvement, or by making process more accurate, fine tuning, micro tuning of the process parameters. So these are the way how improvement can be made. Once improvement is sustainable, process becomes stable, then you go to the fifth phase of the control, how to maintain the improvement, because it's easy to attain the improvement, but sustaining is a very difficult part. So one has to ensure that whatever improvement has been achieved, that must be sustainable, that becomes part of the organization process and the standard operating procedures. So methods are made, the tools are applied to ensure that the control is established in the process so that people can continue to attain the same performance level. So Six Sigma, if you see, the very nice lower specification limit, upper specification limit. So gradually you are what you are doing as the process is improving, variation is minimized. So your the bell curve that becomes higher in the height and the range is reducing. This is a, here if you see the process CPU is used to measure the process capability and Six Sigma is the process. So with Six Sigma process has got process capability of 2.0 and defects are 3.4. So here in case of 1 point, the 5 sigma 1.7, so the process capability that improves as you increase the sigma level and you see that defect which was 3 lakhs per million that has gone to 3.4 parts per million. So just by reducing the variations in the variables, gradually your process becomes sharper and sharper and process capability goes up and your defect rejections come down. So this way process Six Sigma helps to improve quality, reduce cost, reduce delays, increases profitability. So in just a nutshell, this is the way how Six Sigma. Let's now take how it has been applied. Some first, let me take General Electric is used as one of the biggest user of Six Sigma, and they created a benchmark after the Motorola. Here, which has saved the billions of dollars for them. Here, the problem they are making a CAT scanners for the medical equipment. Where the CAT scanner, you must be aware, it's one of the very very powerful tool which analyzes the problems of whole body. So very few CAT scanners you will find in the city nowadays. It is increasing. It is just done for the diagnosis. So G is one of the famous supplier of the maker and supplier of CAT scanners. So what was the problem? The CAT scanner quality complaints were coming in the very frequent in the beginning. Poor performance, high warranty claims, companies reputation was damaged. So because of the poor quality. So what they did, first identify critical to business issues. They identified what are the critical to. So three things were they observed, which is critical to quality: scanning speed of the CAT scanner, life of scanner tubes, and the image quality. So these three things were critical to quality parameters. Now, then what they did, they collected all the data and estimated cost. It means yearly they were spending $20 million just for scrubbing up tubes because they were defective. A lot of warranty failures were taking place. A lot of complaints coming from the customer, reputation was getting damaged. And then they collected all relevant data, why this is failing, what are the causes, how much it is costing, what kind of the frustration was coming in the customers, how it was impacting the patients. Then after collecting all data and evaluating the cost, it was $20 million yearly. So they analyzed the variation and causes of variation and collected lot of data. Here the summary point is given. So they find means in making the tube, the lead, the metallic paint reacting used in the tubes, reacting with the petroleum based oil which was used in the scanning operation. So porosity allowing air to enter in the vacuum. The tube, it has a porosity ceramic item that was causing air to enter the vacuum. Oxidation of metal connectors causing imperfect sealing because of the high temperature during scanning. Heat generated affected image quality because of the heat generated. it was creating a hazy image, and the scanning time was 3 minutes. So these were the some of the causes of variations they analyzed after collection of lot of data, and then what solutions they took and implemented. Use of pre-oxidized metal connectors, already pre-oxidized, so the oxidation chances are not there in the metal connector, so heat is not getting generated. So use of nitrogen instead of hydrogen gas. Nitrogen is inert gas, so it was called miss, the gas was changed, it was impacting the operation of the scanner. Revamp tube heating process. The tube has to be heated at very specific temperature. They made the tube heating process so that it is well within the control limit. Change of few capacitors and insulation to reduce heat generation and improve image quality. And the electronic circuit and electrical uh, circuits, they changed, applied some new innovation, change the capacitor, improve the insulation to reduce heat generation, to improve the image quality. Widen tungsten wires covering X-ray wave receptor cells, create bigger target with improved image quality and speed. So all the design changes were made, and finally monitoring of all above process parameters. Once changes were made, you cannot take it for granted it will impact. Once changes are made, it has to be again monitored by proper data collection and analysis. Once the effect output is coming favorable, then only it can be stabilized. So finally, what they got the results. Customer expectations for tube life. Originally, it was 6 months warranty, actually offered 12 months. It was doubled. Tube life, in fact, means warranty period doubled, but tube life was increased 10 times. Then imaging time of for full body, which was taking 3 minutes, means reduced to 20 seconds. It means every CAT scanning cost has come down to the patients also, because 3 minutes and 20 seconds, now you can see how many times, 9 times. The time taken for one patient, now it has been 20 seconds, means one of ninth time. So this way the cost of scanning to the patient also gone up, and productivity of the scanner also gone up. So heat generation, cooling time, reduced heat generation and cooling time, less time to cool, and productivity of in process scrap reduced significantly because scrapping other tube. So this way, more than $20 billion this has helped in saving. This is one of the historical case study of Six Sigma application. Now let's come to the how it can be applied in small and medium industry. This is the, during consulting, I'm just sharing my own experience. This is a real case study which has been implemented in a small scale industry. So here, as I told, Miss Six Sigma has three things: philosophy, process, and statistics. To start with a small and medium enterprises, emerging corporate accounts, I recommend that you develop expertise in the seven QC tools and follow the define, measure, analyze, improve and control methodology to begin with. As you proceed further, gradually you can make it more statistical, learn it, and further improve it, micro tune it. Let's see how it has been done. The Six Sigma project case, Bharat Stainless Products is a manufacturer of sandwich bottom stainless steel utensils. You might have seen, might be using in your house also. This sandwich bottom, the cookers or the cooking utensils are used, which can be used in the induction heaters where the stainless steel bowl is there. Then the bottom is the sandwich where the magnetic steel, ferritic steel bottom is there where the induction current can generate heat, and in between the sandwich is the aluminum blank is put, so that transmits heat at faster rate. So the production process involves blanking, deep drying, polishing, brazing, assembly, finishing, and packaging. Company was facing a lot of rework and rejection, resulting to high cost of production. Even management was not aware exact data of rework and this is the real situation. They are not knowing what is the percent of rejection and rework was taking place. Only during the consulting, uh, uh, our team collected the actual data. Then only they can know what is the percentage, how much it is costing the company. I calculated all this data and gave them. Based on Six Sigma methodology, here the Six Sigma methodology, DMAT, using 7 QC tools were applied, simple statistics, but the practical way, where the not much knowledge of statistics there. This is the starting point. And once you master DMAC methodology 7QC, you can get a lot of benefit. So details of project are presented in this case study. So the 7QC tools and DMAC methodology that was used, products made by the company, or these are the products, utensil with sandwich bottom. This is the shop floor of the company. They are making a lot of utensils. First, deep drying is done from the stainless steel sheets in this way. Then first operation, then goes many operations. This is the shop floor of the company. Here, these are the power presses where deep drying is done. This is the bridging operation which was causing the problem. If you see, this induction machine is there which is used for the bridging. First, the deep drawn item is kept, then aluminium circle was kept, and over that, a ferritic stainless steel, which is a magnetic, that was sandwiched, and then it was brazed by the machine. So, here now let's see. The rejection was very high, but they were not knowing even the rejection rate. Let's see the define. What are the problem in the sandwich bottom utensils production line? Defects rates are quite high, resulting to a lot of rework, rejections, high inventory, and delay in the product delivery. Goal of the project: reduce the defect rate and develop a quality management system for stable quality performance. A team was formed from the production, from the quality assurance, from the maintenance, from the marketing. So how the it is that then the first is the process map was developed: stainless steel sheets, searing, blanking, deep drying, trimming, polishing, assembly or brazing, inspection and testing, and packaging and shipping. This was the process. This is a deep drying operation where the blanks are stainless steel sheet is flange is made and the deep drawn. Here if you see, the circles are kept. Now the operator is putting on each utensil first circle, then over that a cover of ferritic stainless steel, which is magnetic in nature, that is put. Then the by heating, the brazing is done. So ultimately, the brazed products are aluminium, encapsulated bottom, stainless steel, and cover. So here the sandwich bottom, it is brazed in this way. This is required for the especially for an induction heater, where the induction heating takes place only if it is a magnetic steel. So stainless steel, there are two types of steels. One is magnetic and non-magnetic. Non-magnetic steel is used for the main bowl, but the magnetic steel is essential for the bottom, where the eddy current and resistance is generated that creates heat in the induction heating. This is essential even in case of normal gas cooking also. So this is the sandwich bottom technology. So the project schedule was made: define, measure, analyze, improvement, control. A schedule was made for 6 months. Of course, miss one can take in 3 months, but here the limited number of people were there, so it was 6 months schedule. First, the y and function of x established. What are the various variables why defect was taking place? The- So here, if you see now the actual data collected, June number of total production, total defective, this is from the report. Now they are not knowing the percentage, only something was going. So actually, it was surprising for everybody. The total defect was 14.9%. And these are the causes of defect because these are the variables: scratched, dent, material, base open, and rejection. So these are the various Y factors, and out of that, which were reworkable, this is the number, and scrap 0.25% was the being scrapped, and 14.71% was reworked. So it was costing how much it was costing to the company 2.69 crores per annum. For a small scale company, scrap only 0.24%, equivalent 3.6 metric ton, and cost is 1.150 rupees per kg. It was costing up to 5.4 lakhs. But the rework, because again it has to be whole thing has to be reworked. So 211.89 metric tons of the material annually was reworked, and the cost of reworking was coming 125 per kg. It was costing to the company to 263.75 lakhs. Means a lot of people space machines were used for the reworking. The defective one has to be opened out, and again it has to be reworked, again repolished. So it was costing 263 lakhs. So total percentage was 14.96 lakhs, and this was the cost of poor quality for the company. The analysis, cause and defect diagram analysis was done, and these are the causes of defects were found out. Means defects in the various operation: die setting, base brazing, material quality, and surface defects. Four main areas defects were collected, and the causes were the poor skill of operator, improper die, machine problem. Poor skill, machine problem, material problem, wrong grade of material, wrong thickness of material, defective material, poor handling of material, improper handling of equipment, untrained operator, poor polishing. So these are the solutions. High breakage rate of products die setup. Means poor skill, it was impacting in that way. Improper die, breakage of material. Machine problem, defective product. Poor skill, under overheating resulting to improper brazing. Machine problem, brazing opened. Material problem, defective brazing. Wrong grade of material, defective product. So each problem has got effect. These are the causal factors, and this is effect which was costing high rework, high reduction, and the more cost of operation. Now the solution: improve the production methods and process parameters to reduce cost. Development of quality control plan and standard practice instruction. There was no quality plan, so the quality based on the data and analysis, a quality plan was developed, and the standard practice instruction for the critical process which are impacting quality. Once SPI was developed, the operators were retrained on that. Technical training of operators on SPI by managers and supervisors of the company. Training of supervisors on quality management techniques by lean consultant, and monitoring and review of quality performance. So these were the solutions applied. Finally, how to implement it, a schedule was made within 4 months. This must be a development of quality control plan, standard practice instructions, technical training of the operators, training of managers, supervisors on quality management, implementation, monitoring, and review of quality. A schedule was made, and finally it was implemented, and the data was collected for the 3 months and continuously. Just first 3 months, you see how the defect was there. 5,07,209 items were production, and total defective they observed 26,000, which was a 14%. It came down to 5.14%, and all the defects measured in that area 3.76%, 0.37, 0.02% scrap. So rework level has come, which was 14%. It was brought down to 4.39%, and the the practice further continued collection of data. So the financial gain of from that Kaizen using the Six Sigma, the cost of poor quality factors were the rework and scrap. Before the lean implementation, lean Six Sigma implementation, which was 14.96%, it was costing 269.15 lakhs. After lean, it came down to 5.14%, and the cost of poor quality reduced to 95.24 lakhs, and 173 saving is that 173 lakhs. Reduction in defects and rework by 9.82%, and the saving from 1.73 crores per year. So this is one typical case study. This is actual case study which under my supervision it was implemented. So this way the Six Sigma project can be very well taken by the small scale industries, by emerging corporate accounts, provided they have to learn the DMAT process, they have to master the 7QC tools and apply sincerely. So this is the starting point I recommend for all SMEs to go. And these are the quality control plan, how it was made. Means it was translated in Hindi for the operators. Now it is displayed in front of all operating desks. And finally, after the improvement, again train the operators. Operators were retrained to follow the new standard operating methods, and result of improvement of project quality up, speed up, efficiency gone up, and cost comes down. And this way, the one of the leaders, Six Sigma leaders, famous the word, Jack Wells of G. He says the Six Sigma is a quality program that, when all is said and done, improve your customers' experience, lowers your costs, and build better leaders. So this is the impact of Six Sigma. With this, I conclude the Six Sigma process. Here, if you are having any question, if you could not ask, you can mail it to organizer and I'll answer. Of course, the understanding Six Sigma takes some time because I'm just sharing my own experiences. The first time when I undergone the training of Six Sigma, it was difficult to comprehend it. But here, instead of going to complex statistics, I tried to give you the very practical view how the Six Sigma has been applied. Six Sigma process has been applied in the small industry as well as in the large industry. So, a small industry, they need not begin with a complex statistics, but they must follow the define, measure, analyze, improve, and control process, problem structured problem solving process, and using extensively the 7QC tools, which are much easier to learn. I'll refer that you can go to YouTube, you can take the 7QC tools and refresh yourself and hire some consultant who can help you to apply the 7QC tools with Six Sigma DMAC methodology in your plant. With this, once again, I thank you for your patient hearing, and I'll be glad to reply any question, clarification sent to us through email. Thank you.